Okay.
Hi. Seems to work better. Okay, so good afternoon. I'm Ludovic Cortés, and I'm going to talk about GNU Guix, which is a functional package manager, and also a distribution of GNU/Linux. And I think I'm part of a minority here because I'm going to talk about Scheme and not, statically typed languages. Anyway, I hope you'll enjoy, and my goal is to show you how we manage to make a good use of Scheme in the context of a distribution and an operating system, basically. So I work for NRIA, but I also ended up being a volunteer maintainer for this free software project, which is called Guix. So let me tell you a few words about Guix. So Guix, it's a free software project. It's rooted in the free software movement. It's part of the GNU project, which you've probably heard of. And it's all about building, an API and tools that allow you to deploy software using a purely functional paradigm. So I'm going to give an example later. And you can see this SD thing here. It has nothing to do with SD card, right? It's just a system distribution that we're building around Guix, right? So we have a tool to deploy software in a functional manner. And based on that tool, which is Guix, we're building a complete GNU Linux distribution. So let me give a quick example of what it looks like before I go into more detail. So as you would expect, Git provides you a typical command line interface that allows you to, to search for packages. So let's say you're searching for a game, you can do that, and you get an output describing all the available packages. If you want to install software, let's say you want to install Guix. So Guix is a Scheme implementation that we're using here. And so here you have Guix. And one thing I like here is that we're getting a recommendation about environment variables that need to be set. So I don't know if that's the same for you, but I've been spending quite some time in my life finding out the right environment variables that need to be set. So I'm always happy when I have this kind of recommendation. Okay, and this is all happening as an unprivileged user. Now let's assume I want to remove Guix, and instead I want to install Python, where this is what I'm doing it here. And this is happening in a single transaction. So now I can query the list of installed packages. And indeed, I only have Python available now. Well, let's assume I recognize that this was a mistake now, and I want to roll back to the previous state. Well, that's very simple. So first of all, I can check the available generations of my profile, my set of installed software packages. And here I have 2 generations. The first one contains only Guix, whereas the second one contains only Python. Right. So now I can simply say roll back, and I'm back to the previous generation. So I can list the installed packages, and now I only have Guix. So as a user, this is a pretty nice safety net, right? It's very nice to be able to know that you can transactionally upgrade all your packages or install new software and so on. And if something ever goes wrong, like just before giving a talk, you can always roll back. And that's pretty cool. But why stop here? So this is a GuixSD configuration. So yeah, I should have mentioned, so Scheme is a functional programming language of the Lisp family. So this is why you're seeing all these parentheses, which maybe you're not used to, but maybe you saw them at school or something. But anyway, this could be XML or YAML or JSON, whatever. It's just purely declarative, right? We have an operating system form that describes all the main features and configuration knobs of our operating system. User accounts, file system, locale, and system services. So once I have such a configuration file, which is actually Scheme, but you don't really need to know that when you're using GuixSD, well, I can feed that file to the Guix system command. I can say Guix system build my Scheme machine thing. where scheme-machine.scm is the file that contains the configuration I just showed. Okay, and here I'm getting, as a result, just a file name, a pretty weird file name, in fact, if we display it in its entirety. You know, with this big hash, I'm going to go back in a second on the story behind those hashes. But I will hide it for now. So if we look into that directory, what we have here is just a bunch of files, right? So we have the etc directory that make up that system that I just instantiated. We have the initial RAM disk, we have the kernel, we have, you know, a bunch of other things here. And these are all the things that are parts of my operating system. Right, but this is not very useful, so instead of building it, I can, let's say, instantiate it in a virtual machine. So again, using this Guix system command, it's automatically going to create a QEMU virtual machine. And if I run this script, well, that's going to start QEMU running my operating system that I just declared in a VM. And obviously, I can instantiate it on the bare metal too. That's the whole point. So this is what we have. How did we get there? So what the situation that led us to design this kind of pretty weird, in a way, pretty unusual system? Well, I was at ICFP sitting in this room on Monday morning. You know, there was this keynote about neural networks and TensorFlow, which maybe you've seen. And the funny thing is that one of the first questions from the audience right after the talk was, is there a package manager for neural networks? Which to me sounded a bit funny, right? But in a way, it's pretty natural. You want to be able to share software that your users develop. You want to allow users to develop software, you know, to share it among them. And so if you're doing TensorFlow, well, you want to have a TensorFlow package manager, maybe. Well, apparently there isn't one yet. However, what we do have is a bunch of, you know, language-specific package managers. So we have Cabal, Opam, Cargo, Leiningen, I think, and, you know, Elm, whatever it has. And this is just a very small sample of what's available in terms of package managers, right? If you look at all the widely used programming languages like Python, Node, Swift, whatever, they all have their own package manager. And this is really great, you know, as a developer, because you can quickly get to use all the libraries that you want in your favorite language. And that's fine. But as someone who takes care of a system, well, you know, it makes things a little bit complicated. So in any non-trivial deployment, I should say, of a machine, you're going to be using, you know, a variety of package managers. So you're going to have the distribution zone package manager like apt-get or yum or RPM. And on top of that, you're going to have maybe pip for Python, maybe Cabal for Haskell, and so on and so forth. So how do you go about reproducing the state of a system that uses, you know, all these package managers? And on top of that, these package managers typically implement an imperative style of package management. So what do I mean by this? Well, first of all, they're relying on software that they assume is already available in the system. Like if you use Cabal, it will assume that there's a C library available and, you know, maybe a number of things. If you use NPM, it assumes that you have a C++ compiler available to actually compile its extensions, you know, that kind of thing. And so obviously from one system to another, you might be getting different results. You know, if you're using a different C++ compiler, then NPM might or might not be able to compile your software. Things like that. The second point, but I'm really preaching to the choir here, is that imperative package managers make it hard to reason about the state of your system. So if you're using some traditional GNU Linux distribution, you're running a bunch of commands like apt-get update, you're installing packages, and you know you're trying to have two systems in the same state. Then you're removing a package on one side, installing another one on the same side. And what you would like, of course, is to make sure that state 3A on the first machine is equivalent to state 3B on the same machine. But in fact, because apt-get or similar tools work by modifying the state of your machine, you can't really make sure that you're really getting that, right? So, that's not great. And if you're a DevOps person, for instance, you might want to be able to make sure that you really do get the same state on every machine that you have. So the solution to that is functional package management. So this is not new. This is something that was pioneered by the Guix package manager. And the basic idea is two things. Well, first, we view the build process of a package as a pure function, So we assume that, you're describing your process. It has a bunch of inputs. It produces a bunch of outputs. And this is it. There are no side effects, nothing. And second, software that you built in this way can be viewed as a persistent data structure, basically a graph of immutable values, right? Each build package, each package artifact is an immutable value in a big graph of packages. So that's the idea. So how do we achieve it? Well, first, when you build a package like this using Guix build, you build it. Well, Guix will make sure you build it in an isolated environment, in a CH root, such that there is no interference with the rest of the system. So if your OKML recipe didn't declare, another package as an input, then it simply cannot use it, right? And that's how we have that vision of build process as pure functions. And when you build it, well, you get a result like this with those big hashes, and the hash is a hash of all the dependencies that led to that result. So let's say to build OKML, you might need a C library, a C compiler, you might need build scripts, things like that. Well, all of them make this hash that we have here. So at this point, I must ask, how many of you have heard about Guix and NixOS? Oh, it's, maybe 2/3 of the audience. Okay, so if you've heard about Guix and NixOS, well, you may be wondering, well, we know that already, right? And indeed, this is the very same paradigm that Guix uses. So what's different here? Well, this brings me to my second problem that we're trying to address. And it's the problem of domain-specific languages, external domain-specific languages. Just to give you a flavor, this is a package recipe written in the Guix language, which is an external DSL, right? So what we have here, we're defining a function, then calling a function that will create a derivation that represents our package. But there is actually no package abstraction in the language. So some time ago, when I was using Guix, I was trying to write a tool that would, traverse the whole list of packages, and from that, find which packages needed to be updated compared to upstream. But the problem is that since you don't have a package abstraction, well, first it can be hard to identify which things are actually packages, and second, it's an external DSL, so you would first have to convert all the Guix package distribution into XML, then parse that into my program, and then eventually do the job that you want to do. And this is quite inefficient and inconvenient, and I would claim that it precludes a number of tools and implementations. Plus, on top of that, Guix is mixing bash snippets inside recipes, which brings its own set of challenges because you have to take care of escaping and such, and you're just concatenating strings that represent big bash programs, which is not always so great. So the approach that we take in Guix is to use scheme all the way down. So I recently stumbled upon a talk called Escaping DSL Hell by having parentheses all the way down. And I thought, well, this is exactly what we are doing here. This is great. So this was a talk about closure, but I think it kind of applies here. I recommend it. So this is what our typical package recipe looks like. So again, parentheses. you know, it looks like, again, XML or anything declarative, but it's really scheme, in fact. And what we're doing here is we're defining a global variable and giving it as a value a package record. So it's just a plain scheme object. So if I go to Emacs here, well, the Emacs IDE can tell me that, you know, it recognizes the keywords if you look at the bottom line here. So, you know, it can see that these things are variable references. It can say that URL fetch is a variable. And, you know, we have, yeah, GNU build system here is a first-class variable as well that describes how the package is going to be built, and so on and so forth. And if we look at a slightly more involved example, like grep, you know, the grep command, well, this one has a dependency here. And we see that it depends on Perl. And again, Perl is simply a scheme variable, right? There is no magic here. This is all purely embedded in scheme. And again, this also works at the operating system declaration level, right? So remember I showed you that operating system declaration before? And well, we're just manipulating normal scheme values. So we can say, for instance, in my system services, I want to simply const the OpenSSH service value to the base services, right? And this is all, you know, functional in a general purpose language. So I can also use remove to remove services, system services that match a certain predicate. Or I can do more complicated things like this, using this modify services macro. So essentially, I'm defining a list of services here using this modify services macro, which expands to map, essentially, plus a lambda. And what I'm saying here is that I want to change services of this and this type by changing their configuration, right? So this is all functional code. What I'm saying here is that I'm taking the min get TTY configuration and changing the message of the day, while keeping the other parameters intact. And same for the power management service. And I must say that it has worked pretty well in practice, right? You know, we have the theories that embedding domain-specific languages is fine, but you never know until you've actually done it whether it's fruitful. In our case, it's really been fruitful. So for instance, we've had people implementing new user interfaces. So one is in Emacs, one is a web interface, and we have tools like Guix refresh, which can do automatically update packages, package definitions. We have Guix lint that contributors can use to check for coding style issues. We have Guix graph to view the dependencies of packages. We have things like Guix system extension graph that show how system services are composed in an operating system declaration. So embedding DSLs is the way. So far so good. We have a scheme API to declare packages, to declare operating systems. How can we go beyond that? So usually, if you look at a typical GNU Linux system, there are a lot of things that are addressed in an ad hoc manner. One example is the initial RAM disk that is provided to the Linux kernel to bootstrap the machine. And it typically uses very ad hoc software like a special libc, special commands and everything, just to build this little init.rd archive that boots the system. What we're doing here instead is that we have an API. You give it a scheme expression, and it produces an init.rd that will run that scheme expression, right? And the key here is this hash tilde thing. So if you're familiar with some Lisp flavor, it's a bit like quote, except that here this mechanism allows us to embed all the dependencies of the expression inside the init.rd. So this is really code staging. We're generating scheme code that will run when we actually boot the system. And so if you followed, we boot Linux liber, the Linux kernel, then we have this initial RAM disk written in Guile scheme, and we also have an init system written in Guile scheme, and then we have applications. So again, if we look at the init system, we can do code staging as well. And indeed, what we see here, we have this hash tilde form, which is also a way to say, well, here I'm providing a scheme expression, right? But this scheme expression is going to end up in the configuration file of the init system, right? And this make fork exec constructor procedure that we're calling is actually part of the init system's API. So by having different pieces written in scheme, we can actually generate several layers of scheme code, and eventually we get a system where everything can be, well, not everything, but many things can be approached from the scheme side of things. Okay, so time to wrap up. So the takeaways here are, we have a distribution and a bunch of tools that are available as scheme libraries. So everything from packages to operating system definition, system services is available as a simple scheme library, no magic here. And because of that, we have very easy hackability. It's very easy to hack this system. And we're using code staging capabilities to glue all these pieces together. And I should mention that all these facilities are facilitated by Scheme here, because Scheme is an extensible programming language with macros. Okay, so this is it. So you're very welcome to help out and join us now, share your parentheses. You can install the distribution either on top of your GNU Linux system or as a standalone distribution. You can use it, report issues, and above all, you can share your ideas, bring new ideas in. Thank you.
Hi. So yeah, two questions. Do you have some facilities to migrate a Nix install to a Guix install? And the second question is, what do you think a statically typed language would bring or remove, I guess, because of the macros, the things you have with Scheme?
Yeah. So do we have facilities to migrate from a Nix system to Guix? Not really. So under the hood, Guix and Nix use the same low-level representations, which is called derivation, if you're familiar with it. So in theory, you should be able to use the same store for both Guix and Nix, but that's about all we have, in terms of migration. Second question, a static type system. So what would it bring? Well, so I guess one of the problems might be with a static type system is that in fact we rely quite a lot on dynamic composition. So one of the features that we provide is that people can have their own set of package recipes, and they can just put it in Guix package path, and the tools will automatically pick them up and use those packages as if they were part of the main distribution. I can imagine that if we were using a more, statically typed system, maybe this could cause problems because we would have to add additional compilation phases and so on. It would also be fruitful, on the other hand, to have a static type system, I'm guessing. Like if we want to enforce certain properties inside package recipes themselves, making sure people provide the right kind of values in there. Although we can also do some of simple checks at expansion time, macro expansion time. And also for code staging, in a way, this could help, make sure that you provide a correctly typed expression that you're staging, I'm guessing. Yes.
So I really enjoyed the talk. I'm one of the maintainers of OPAM and Docker as well. And one of the things we've always struggled with in these systems is network virtualization. So if we want reproducible builds, there's been a number of solutions that help with reproducible builds like Guix when you have no network connectivity. But I think as a group, we've all failed to figure out how do we build distributed systems that when we try to rebuild this thing in a year or two from now, if there's any network dependencies like packages or signatures, to reproduce those as well. So just wondering, as a project, have you thought about or interested in an effort to virtualize networking as well as individual single host builds?
So have we thought about virtualizing network access is what you're saying, right?
Yeah, so for example, curling a file from the internet.
No, so actually the approach we're taking that the build environment doesn't have network access at all, right? which means that we are forced in a way to specify all the inputs beforehand in our recipes. This has worked pretty well for us so far, because in practice, one of the problems we could encounter is if some remote server disappears, for instance, then you can no longer retrieve the file. But actually, we always detect this kind of problem, and we also have content-addressed mirrors that we can use when that happens. And well, yeah, so I guess that's the answer in our case, and it works quite well.
If you could just bring up the description of the Hello World package.
Yes.
Or any other one. So one thing that struck me with this is the fact that when a new version of that comes out, you now have to edit that twice. You've got to update the version number, and then you've got to update the SHA. But yes, the rest of the actual package definition is probably going to say the same. Have you thought about abstracting that out? I know that Xherbo had the notion of you had a per package library. So quite often you'd have the library, which is a default definition of how to build and install that package. And then an actual version number would just be, okay, we'll just use that library and set this version, and then with this SHA, with this hash. And that way it'd be less editing of the actual package descriptions. You just have this abstract, okay, here's how to make a hello package. I want to make the hello package with this version, this hash.
So what you're suggesting is basically having a separate version to hash mapping.
Yes.
Did I get it correctly? Yeah. We haven't really thought about it, I guess.
I suppose if you're only having one version of any package, it's not a big deal. It's more when you might want to have multiple versions of a compiler rather than copying, though macros might make it easier, but rather than having to copy the actual definition multiple times.
Yeah, right. So for some packages, we actually provide several versions of the package. And in that case, obviously, we don't copy the entirety of the recipe. So there are a few things we can do. We can inherit from this record here, which means I'm just copying all the fields except, let's say, the source field. And we can also write a function that returns one of those origin forms. And so that's what we typically do if we're providing several versions of the same package. We have a function that you give it the version and the hash, and it returns the origin form. And from there, you can have several instances of this package record.
Okay, let's thank Ludovic.
Thank you.
We're going to reconvene at 4:40.